This is a lesson on algebraic fractions. We first take a look at how we simplify algebraic fractions by first looking at a numerical example. In the numerical example, we see that we need to express the numerator and the denominator in terms of factors. Then we cancel away the common factors, giving us the result 2/3. Similarly, in an algebraic fraction, we look out for common factors. We have 2 cancel with 6, which we can write as 2 times 3, and 2 is cancelled away, so leaving behind 3. A square is a times a, and 1a is cancelled away, so 1a is left. And b cubed is actually b square times b, and b square is cancelled, so 1b is left in the denominator. In the next example, we must first expand the terms in brackets, which gives us 2a square b times 2a square b. Then we multiply. 2 times 2 is 4. A square times a square, a to the power of 4. B times b, b squared over 8a square b. We cancel 4 by 8, 8 by 4, giving us 2, and a to the power of 4 cancel with a to the power of 2 is a to the power of 2, and b square cancel with b is b in the numerator. So these are also factors, and in the next example, the factors are binomials such as x plus 2 and x minus 1. This represent a single number, a single factor. So once again, factors which are common, we can cancel them away because they are factors, they are multiplied, then we can cancel. Now, so 2 cancel by 6, we have 3, and a we cancel away. So what is left is x plus 2 over 3. Similarly, we have the factor 3 by 6, 3 over 6, which we can cancel to have 2 in the denominator. And here x plus 2 square cancelled by x plus 2 cube. X plus 2 cube is x plus 2 square times x plus 2, so 1x plus 2 is left. The next example is a special case. You notice that x minus 2 is in the numerator, but in the denominator is 2 minus x. So we need to rearrange it by taking out the sign. So when we take out the sign, we put it right in front, and we switch the terms. Okay, so 2 minus x is equal to minus x minus 2. Right, so when we take out the sign, we can switch the position of the terms. So now the terms are exactly the same, so we can cancel it away. So what is left is in the denominator, and there's a negative sign here, is negative 1 over b. In the next example, we see that there are no factors, so we need to factorize before we can do any cancellation. We cannot cancel like this because for addition or subtraction, we can't just cancel like this. Right? It's not correct. Only when it is multiplication, then we can cancel. So we only can cancel when there are factors, not addition or subtraction. So we need to factorize first. Now the numerator is 7p minus q. So this gives us an idea that there should be a 7p minus q in the denominator. So looking at the denominator, when we take out 8r, which is the common factor, we have q minus 7p. Now note that the order is again different. Therefore, we need to take out the sign and switch the position of the terms. When we take out the sign, we put it right in front. Right, so now we can cancel and giving us negative 1 over 8r. Now we look at this example. We have d minus 4 in the denominator, so we should have a d minus 4 in the numerator. So usually there are factors which are common. So now we guess that there is a d minus 4 in the numerator. So therefore that makes our factorization easier. So this must be d plus 7. Because 7 times minus 4 is minus 28. And we can check the middle term, which is 7d minus 4d, which is 3d. So now we can cancel, and the result is in the numerator, or just simply d plus 7. Therefore, in order to be good in algebraic fractions, you need to know your factorization very well. Such as in this case here, if you see there are 4 terms, it is factorization by grouping. So factorization by grouping means that this expression can be divided into 2 groups and each group has a common factor. But if we examine the first group, there isn't any common factor. Therefore, we need to rearrange the terms, putting the m terms together. And since the first term it has an a in front, the second group should also have a in front. And 5 minus 4n. Now we can factorize. 5m is common, and in bracket we have a minus 1, 3a minus 1. So here, taking out 4n is common. We have 3a minus 1. So 3a minus 1 is a common factor. Now, So now 3a minus 1 is common. We take out. And we have 5m plus 4n in the numerator. So now on examining, we should also have a common factor in the denominator, and we know that the denominator doesn't have a, so the common denominator in the denominator is 5m plus 4n. That means to get a 5m square or a minus 5m square, we need to have a minus m here. And then to get 8n, we have 2n plus 2n. Okay. So now we can cancel the common factor, and our answer is 3a over 2n minus m. In the next example, we should also recognize that there is a difference of two squares, but there is a common factor which we have to bring out first. So the common factor is 3. Once we take out 3, then we can see a difference of two squares. And in the denominator, if you are good in your factorization, you will also notice that this is a perfect square because we have two positive squares at both ends. So a perfect square has two identical factors. To get 4a squared is 2a times 2a. And to get a 9b squared, we have 3b times 3b. And since the middle term is negative, it is a negative perfect square. Okay, so we have 2a minus b in the denominator, meaning that we should have a 2a minus b in the numerator. So when we factorize, we know that a difference of two squares will give us a positive binomial and a negative. So that is 4a squared is 2a times 2a, and 9b squared is 3b times 3b. So now we have a common 2a minus 3b. Which we can cancel. We have to leave our answer in a factorized form for the numerator and the denominator. Now we will move on to multiplication and division of fractions. Again, we start to look at a numerical example. We know that when it is multiplication, we can simplify by cancelling away the common factor. Common factor here is 3. And the common factor here is 7. And then we multiply the numerator times numerator to give us 4. Denominator times denominator. And when it's division, we need to invert and convert to multiplication, invert the fraction after the division sign. Then we can cancel. And since it's a numerical case, we have to give our answer as a mixed number. Okay, so remember that when it's multiplication, then we can cancel the common factor. And when it's division, we have to change it to multiplication. Here the common factor is b squared, and then 8 is cancelled with 6, and what is left is numerator times numerator. We have 3a4 over 4. Okay, so here we need to invert. Change the multiplication, invert. Don't do any cancellation first. Okay, so now it's multiplication. We can cancel common factor like k, and 25 we cancel, it's 5. 7 cancel with 28 is 4. It's best to cancel in pencil so that they won't mess up. Alright, so m cubed cancel with m is m squared, and n cancel with n cubed is n squared. Numerator times numerator, we have 20n squared over m squared. We have to be very careful that we won't miss out any numbers. That is why sometimes it's better to put all the numbers together. This is 47, 4 over 27, 9 over 16, and 20. Put all the numbers together, multiply the numerator, q cubed, and multiply the denominator, which is p cubed q squared. Once we separate the numbers and the letters, it's easier to see whether we are cancelling all the numbers. This is cancelled, 3, this is cancelled, 4, and 4 is cancelled, 5. So this is a neater way of doing the working. So we have 5 over 3, and here we cancel, there's a q in the numerator, p cubed is still in the denominator. Okay, so now here, when there is a square, we need to open up the square first. This is PR times PR, so P times P, P square, Q square, over 45Q multiplied by 5 over PQR, and multiply by Q square R square over 12. If there are only a few numbers, we can just cancel, but when there are too many numbers, it's good to separate it. Alright, so this is 9, and that's about it. And then the common factor, P, you see, so it's actually better to work out the numbers first. Right, so we work out first. We have P square, Q square, and R4 over 9 times 12 is 108, and we have P Q square R. When we multiply out the numerator for the letters and the denominator, then we can clearly see only one term in P in the numerator and one term in P in the denominator. So we can cancel easier. Right, this is P left, this cancel away, and R cubed. Okay, so what is left is P R cubed over 108. Look at some more examples. In this case here, we don't have factors, so we can't just cancel like this. Remember, we need to factorize first. So in the first case, we have to factorize the denominator to give us 4 2m plus 1. Okay. Remember that the numerator gives us a clue that there must be a 2m plus 1 in the denominator. So now we can cancel the common factor. Cancel. Left behind 2m plus 1. And here m is cancelled, leaving 1m. 35 cancel. 2 times 7, 5. And now we can multiply out the numerator. Leave the answer in brackets. And the denominator, 4 times 5 is 20. Oh yes, we need to cancel one more time. To get a 2. So now the denominator is 10m. We have to do this very carefully. Okay, so now, yeah, you can factorize first. M is common, n plus 3. And in the denominator, we have m is common again. mn is common. Right, so we have m plus 3. Right. So here we change to multiplication, and now the numerator n bracket m plus 3, and the denominator, this goes to the denominator, which is n bracket n plus 3. Know that there will be common factors. If there are no common factors, you might have done it wrongly. Okay, so n is common, n plus 3, n plus 3, and what is left is just simply 1 over n. So once again, factorize first. 2 bracket x minus y. So we know that there should be a x minus y somewhere. In the denominator, we have 4 terms, which is factorization by grouping. There is a common group here. Ax is common, x plus y. So x plus y is a common factor. When we take out y in the denominator, we have x plus y. And now in the numerator, we have 2x plus y squared, and the denominator is a difference of 2 squares, which is x plus y times x minus y. So now we cancel the common factor. No, before you cancel, you must first factorize this. We can cancel the others first. Right, there's 1x plus y and x minus y. Okay, so what is left now is 4x plus y, and the denominator, taking out x plus y as a common factor, will give us ax plus y. Okay, so common is x plus y, take out, left behind ax plus y. Now we cancel, and this gives us 4 over ax plus y. Okay, now this looks very complicated, but we need to factorize numerator and the denominator. Invert this, and this goes to the numerator. So it's a 9p minus 4q, and in the denominator is 5p plus q squared. Here we have 2 is common, and then this is 9p squared minus 4, 2 times 4, 2 times 9, q squared. Okay, be very careful. This one can't be cancelled, because when we factorize this, it will be 3p minus 2q and 3p plus 2q. It's a difference of 2 square. You can check that you have done it correctly. This is 18p square and minus 8q square. Okay, so now if you factorize this, notice that I did not factorize the top part yet, because here we know that this is 3p minus plus 2q and 3p minus 2q multiplied by 9p minus 4q. Now there should be common factors in the numerator, so therefore we know that the numerator is all plus, so we could have guessed that there is a 3p plus 2q and a 5p plus q. Well, we can check. You can check by checking the first term, which is 3p times 5p, 15p square, and the last term is 2q square, which is correct, and the middle term is 10pq plus 3pq, which is 13pq, right? So our guess is correct, that there is a common factor which is the same. So in this way, we don't need to really factorize a lot. Okay, so now what is left is 9p minus 4q in the numerator, and in the denominator is 3p minus 2q times 5p plus q. Right? There are no more common factors. We leave our answer all in bracketed form. In the last two examples, the fractions looks complicated, but when we have fractions like that, we rewrite it as a fraction divided by this fraction. So here, change the multiplication, that this becomes 1 over m minus 4. Then we can cancel. So similarly here, we rewrite this divided by, or we can straight away change the multiplication, but anyway. Okay, so we change to multiplication. And the result is a n. Next, we look at addition and subtraction of fractions. In the numerical example, we see that when the denominator is the same, we can add the numerator. And when the denominators are different, then we will have to make the denominator the same by finding the LCM, or we just simply look at the factors in the denominator. For example, here we don't have a factor of 3, so we multiply by 3 over 3. And here we don't have a factor of 4, so we multiply by 4 over 4. So that the denominator now is 12. Common denominator is 12, so we put under a single denominator. And the numerator is 3 times 3, which is 9. 2 times 4 is 8, so it's 1 over 12. So now we look at algebraic case. You see that the denominator is the same, so we can just add the numerator. So we have 8 over 2ab, and we have to reduce this to 4 over ab. Okay, so when the denominator is different, so let's examine the factors again. 10 has a factor of 2, but we don't have a factor of 2 here, so we multiply by 2 over 2. And here we have a factor of a, and we don't have a factor of a here, so we multiply by a over a. So now check that the denominator is now the same, 10ab, so we put it under a single denominator, 10ab. Numerator is 2a times 4 is 8a minus 3, and that's the answer. Okay, now we see that the denominator is a binomial, but when the denominator is the same, you can put everything under the same denominator at the numerator. And once again, the denominator is different. So here we have a factor of 2, but here we don't have a factor of 2, so we multiply by 2 over 2. Now we have 10x, but we don't have x plus 1, so we have to multiply by x plus 1 over x plus 1. Right, so the numerator now is multiply 2 times 4, 8, bracket x plus 1, and minus 3 over 10x x plus 1. Simplify the numerator, multiply in, we have 8x plus 8 minus 3, so 8x plus 5. Right, now we look at further examples. In this case here, the denominator are not factors, so we need to factorize the denominator first. Right, so factorize the denominator. We have 4 over 3 bracket m plus 3 plus 1 over m plus 3. So we don't have a denominator of 3 here, so we multiply by 3 over 3. Now the denominator is the same, is 3 m plus 3, and at the numerator we have 4 plus 3 is 7. Okay, factorize the denominator. We have 3 over this is 5 is common, then we have 4r minus 9q, which is the same as this, but except that it is in the reverse. Here 9q is behind, so we need to rearrange this. Remember, we have learned it earlier on how to invert it. We take out the sign, which is a negative sign, so this becomes negative times negative is positive. Or we just change the sign in front and switch the terms to 4r minus 9q. So now the denominator is the same, except that now we don't have a factor of 5, so we need to multiply by 5 over 5. And now the denominator is the same, 5 for r minus 9q. And numerator is 40 plus 3, 43. Okay, once again, we factorize this. Well, we could have guessed that there could be a 7p plus 4 in the first factors. So we can try 7p plus 4, and then to get a p square we times p, 7p times p, and to get a 4 we need to multiply by 1. It's all plus. Check the middle term, 7p plus 4p, 11. Yep. So now this one need a p plus 1 because there is no factor of p plus 1. So now the denominator is 7p plus 4 times p plus 1. Numerator here is 3 plus 2p plus 2, which is 2p plus 5. Remember to leave the answer in factorized form, both the numerator and denominator. So again, factorize the denominator, and once again we can guess that we have a same factor of 3q minus 8r. And to get a 40 we have a 5r, and to get a 6 we need a 2r, and this is negative, so this has to be positive. Negative times positive. Check the middle term. This is 16, negative 16 qr. Now, sorry, this is a mistake. This must be a q. 16 negative 16 qr plus 15 qr will give us negative qr. Okay, so everything is right now, and this is short of a 2q plus 5r, so we need to multiply 2q plus 5r in the numerator and the denominator. That gives us a 8q, 4 times 2, 8q plus 20r minus 9 over the factorize. Next, we move to algebraic fractional equations. For algebraic fractional equations, we have two methods or two approaches. In the first one, we want to get rid of the denominator by multiplying throughout by the LCM. Remember that the LCM is where all they must have the same factors. So here we have a factor of 3, and then we need a factor of 4, so it's 24, right? 24 is the common factor, a common LCM. So we multiply throughout by 24, the LCM. We multiply through LCM so we can cancel the denominator. Cancel the denominator. And cancel the denominator. We can only multiply throughout by the same number for equations. So for expressions which we have done earlier on, we cannot multiply throughout by the LCM. Okay, so this is 4 times 7 is 28. Right, so now you see that once we multiply throughout by the LCM and cancel the denominator, the expression has no more denominators. So we have 9a minus 12 plus 6a plus 18 equals to 28. And here we have 9 plus what is 15a, and this is 6, bring over 22, and 22 over 15, which is 1 and 15 and 7 over 15. We need to write as a mixed number for numerical answers. Well, here we see another method, that is to make this into a single fraction. So to do that, the denominator must be the same. So we multiply by 2 over 2, so that the denominator now is 8. This is 3a minus 4, and here is 2 bracket a plus 3. Right, so now 3a plus 2a is 5a, minus 4 plus 6 is plus 2. Now we can cross multiply. Okay, so we cross multiply, we have 30a plus 12, and this is 56, which we have 30a equals 56 minus is 44, and this divide by 2, we will have 15a equals to 22, and we can see that this is the same answer. Right, so we have two methods: multiply throughout by the LCM, or make into a single fraction on each side, and then we cross multiply. Here we have an example where we have a single fraction on each side, so we cross multiply. That is 4 multiply diagonally equal the product of the other diagonal. Expand it. We have 24 minus 3m, and here we add, and here we subtract, so we have negative 4, and m is negative 4 over m, 4 over 11. Alright, now in this case here, we have to be very careful. You see that the denominators are actually the same, except that it's in reverse, and therefore we need to take out the sign again. So taking out the sign means that the minus here change to plus, and we can reverse the term. So this will be just a common denominator, and numerator is 23. Right, so here we can cross multiply, and so 9 minus 2y is 1, and 2y equals to 8, y is 4. Well, we can check whether we have done it correctly. We can substitute the values in here, and if it equals to 23, then it's alright. Okay, now we see that here, well, we can have two approaches. We could multiply throughout by the LCM, and the LCM is actually y plus 2 times y minus 2. Or we can make it into a single fraction, whichever way, and then cross multiply. Alright, so I think I'm going to multiply throughout by the LCM, which is y plus 2 times y minus 2. And here is the same thing, y plus 2 times y minus 2. And y plus 2 times y minus 2 is multiplied on this side as well. Okay, we multiply throughout by the LCM. In this way, we can cancel the denominator. So here I will have y minus 2 times 4y minus 12. And here I cancel. I will have minus bracket y plus 2. And on this side is 4 times y squared minus 4. Right, so this one multiply out will give us 4y squared minus 8y minus 12y is minus 20y plus 24 minus y minus 2 equals 4y squared minus 16. Okay, 4y squared minus 4y squared 0, and this is now minus 20 minus what is minus 21y, and this is 24 minus 20 minus 2 is 22, so brought over, so is negative 38, and y equals to 38 over 21, and that gives us the answer. Now in the last example, right, yeah, maybe since it's a fraction here, I could make the other one into a fraction by multiplying by to get the same denominator. The denominator here is 5 minus 3x, so I need to multiply by 5 minus 3x over 5 minus 3x. So now the denominator is 5 minus 3x, and numerator is 2 times 5 minus 3x and plus 10. Okay, so simplify it. We have 10 minus 6x plus 10 over. Okay, so we can cross multiply once we have make it into a single fraction. We have 20 minus 6x, 5 minus 3x. So here now single fraction, we can cross multiply. So cross multiply will give us 25 minus 15x, and here is 20x minus 6x squared. Now you notice that this equation actually becomes a quadratic equation. right? So if we simplify the equation, we have minus 35x plus 25. So we need to factorize to get the answer. We have 6x minus 5 and x plus 5. Right, check the answer. Oh, this is minus also. Right, so we have two answers. X is 5, 6 and x is 5. Right, that completes the discussion on algebraic fractions. Thank you.